Hi, everyone. This is our senior CS230 final project. My name is Matthew Baker.
My name is
My
Carissa
name,
Ade.
my name is Genesis Diaz.
My name's Gordon Montrose.
My name is Rayel Tiamela.
Our problem statement was to create a superhero character ranking system, which the application will allow us to sort the characters by their rating, ranks, or their user by using the user input to insert characters with their fighting moods, their level of strength, and yeah.
Considering the task at hand, we will use hash maps to create different category for characters, and these characters will have a list of moves. Once the character is added, we will have some sort of integer determining what their rank/strength level is. And to solve this, we will create a binary tree that automatically sorts the ranks. Finally, the tree will print the ranks in descending order. We will also allow the user to delete a character or one of their moves, edit a character or one of their moves, and find a character or one of their moves using the binary tree.
Okay, so one of the first things that we did was we created a header file and like the main CPP file. So the header file was pretty much called superhero, and that was going to handle all the functionality, and then we're just going to transfer that over to the main file. So the first thing that we did, we created a struct named the ranked node, and this struct will pretty much hold the variables that will be used to implement the binary search tree. And this project relied heavily on using maps to store the characters' moves, and the character's rank. So within the private, we use the first attribute, which is a map for the binary search tree, and that map will hold a string that will represent the character's name, and then the rank node struct, which will represent the ranks. The next map will hold a string, which will represent the character's name, and then a list of strings, which represents the moves. And then the string called superhero is defined, and that will pretty much represent all the characters' names, and we defined it within the private, so it can just be used within all the functions. And then within the public, we created the empty constructor, and then we defined a function that's called the get new rank. We're pretty much taking a string and an int, the string which will represent the name, and then the int which will represent the rank, and made it so that it dynamically allocates memory for like a new rank. And then it sets the rank member to the int value, and then it does the same for the val member, which will represent the name of the superhero. It then initializes the left and right pointers to the node, and then it returns the new node. And then all the functions that are used within that application are defined. Okay, so this is the hash table implementation of functions. So the first thing that we did for the hash tables was the add character name. So this function was pretty much like the hardest part because it took a lot of trial and error, and it was like the basis for making sure that the rest of the functions worked. We had a couple ideas, and the first thing we did was to implement the hash table without any user maps, and then to try to make the user insert the name, like of the category the super would be in. But like that did not work at first. So then we tried to make it like a key, and the user picks from the menu, but that also didn't really work properly. And then we decided to use a constructor and then use a map to assign like a subscript and like assignment operators. However, when you printed it out, it'll always show like the subscript and the assignment. But rather, I was trying to make it so that rather than showing like the subscript, it would show the names of the superheroes within that subscript. But it wasn't doing that. And so I went back to the hash table code that we did last time. And in my main, I was the vector, and that stored how large the table was. So I thought, okay, if I had a vector string that holds the characters and assigns them to the another string that represents the categories, then that will probably work and it will like pass them by reference. So that was basically what I did. And the code pretty much just like defines a string called category, and then in the place of different categories and actually use it to input the choice. Based on the choice, a switch case is used to assign the number to the category that the user picked. And then the user is asked to insert the character's name, and then the character's name is added to the table, like it's added to that category using the pushback function, and has a category that the user picked as the key. So pretty much any new character that is put in the same category is like appended to that category. And then the next function I did was the delete character function. So this pretty much like handles like the deletion of a character from the hash table. The function takes in a map of a string and a vector that will be passed to the hash table. And then asks the user what character they want to delete. And it uses a for loop to loop through the existing hash table using the I to represent the key value pairs. And then it uses the find function to see if the name that the user inserted matches a name in the table. Like it checks through each of the categories and see if it matches a name in the table. And if it does, then the erase function is used to delete that superhero from that category. And then if the character is not found, a message is displayed to handle that error.
All right, so find a character. This function is designed to enhance user experience by navigating through the database of superheroes. The process begins with the user selects the find a character option from the main menu. The program asks the user with a clear question: what is the name of the character you want to find? The user provides the name of the superhero they are looking for. If the superhero is found, the program notifies the user, enhancing user confidence in the search. If the superhero is not found, a clear message will display indicating that the superhero is not present in the database. The Find a Character feature provides a user-friendly and a great way for users to locate specific superheroes, making superhero information more accessible and enjoyable for the user. Display characters in the hash table. The process indicates when the user chooses the display character hash table option from the main menu. The program displays the categories present in the hash table, providing users with a clear overview of the available superhero journeys, which is like comic/book characters, animate, and etc. For each category, the program lists the superheroes associated with the category. This creates a structured presentation where the user can quickly identify and navigate through superheroes. The output is presented in a readable format in the form of a table or series of lists. Each category is showcased along with superheroes falling under it.
Map implementation and functions. Add character move function. The add character move function first starts in superhero within private, where character names are linked to a list with their special moves. In the add character move function, we first declare a move as a string variable, then prompt the user to enter the name of the character's special move. Then it creates a list named character moves with the move entered by the user as the first element within the list. The list is made so that it can be linked to the character that is made within the hash table's add a character function. Lastly, it creates the list for the move and it inserts the character's name as the key and a move to the value within the movement. This is how the signature move is linked to the character within the character creation process. Display all characters using mapping. The view all characters map function aims to display all the characters' names as well as a list of all the moves associated with each specific character. It uses 2 for loops. The first loop prints all the characters' names within the order they were entered by the user. Then it prints a dash to separate the characters from their move to make it more visually pleasing. The second loop or inner loop prints all the moves for each character which was entered by the user. An example is shown: Spider-Man, web swing; web shooter, Spider Sense; Steve, use attack place; Goku, Ki Blast, Kamehameha, Super Saiyan.
Binary search tree implementations and functions. The add character rank function was started by asking the user to enter the rank of the character they just inputted. With this information, we will make use of the get new rank method, which creates a new node that saves the rank and the name of superhero to the respective variable of new node to the pointer rank and new node to the pointer value for the name, and assigns both right and left pointers to null, and lastly returning the new node. Subsequently, this adds to the tree of character as you add more characters to the program. The find character by rank function first asks the user for the rank of the character they're searching for. Once it accepts this input, it uses a for loop to go through the rank, and at each object in the iteration, it calls on the rank variable of that object within the map and compares it to the value entered by the user. If it matches the rank, then it prints the name of the superhero and returns true. However, if it doesn't, then it prints the superhero was not found and returns false.
Display characters. In the menu option, number 6, it will have you an option to select this character, which would use the function view all character tree that plays a critical role in sharing the superhero ranks. It uses the transverse, it outputs the transverse order of the ranks and prints out the users, the superheroes, and the ranks.
Improvements to make. We would improve on the rank display. Right now, the code displays the character's name and their rank next to it. If we have more time, we will make changes so the characters are in order according to their rank. We would also do more error handling in the code. We would also try to display all the categories at once, regardless if a character is saved within them or not.
Timeline of coding process. So November 17th, that's when our idea was created. The 27th of November is when we first had our online group meeting. The 28th is the beginning of the PowerPoint creation. The 29th is the in-person meeting, slash when we made all our roles and decided what everybody was going to do. The 29th also is when we had the creation of the group coding website. We use Replit. The 4th of December is our first group check-in to make sure everybody was doing everything. The 7th through 8th of December, we were finalizing the code. The 9th of December, we were finishing up the PowerPoint presentation. And the 10th is when we turned in everything.
Okay, we're now going to run our code and show how we did it. Okay, so this is a code, this is the hash table, and this is the main. You guys see that? Like the running screen?
No, we can't.
It's okay. Okay, you see now?
Yep.
Okay, so I'm gonna enter character. Oh no, what is a special one, honey?
Flight. Oh, that works.
How does the flight? My character two. I don't know. Fireball. Okay. Now I'm going to find it. I'm going to find Goku because it's ranked 7. And he found on display a lit map. That's the character and their superhero move. In the binary tree, that's the superhero and their rank. And then the hash table, that's the categories they're in. And I'm gonna delete, well, for the you can find the character. I'm gonna find Goku. And he's found. And delete character. Superman. Delete it. And I display the hash table. He's gone. That's how the code works. Thank you.